Welcome to 3D Print Pulse, your essential weekly update from the cutting edge of 3D printing and additive manufacturing. Every week, we bring you the most important news and developments. The episodes are crafted by All3DP's expert editors and voiced by text-to-speech so that we can go hunting for news again. Ready for the latest? Let's dive right in.
For the last decade, simply having 3D printing on your resume was a golden ticket. Companies were desperate for anyone who knew the difference between FDM and SLA. But in 2026, that party is officially over. According to a new salary survey from Alexander Daniels Global, the industry metric has completely flipped. We have moved from a quote, talent shortage to what the report calls an opportunity shortage. Globally, for every single job opening in additive manufacturing today, there are 154 applicants. Why the sudden squeeze? The answer is maturity. The industry has moved out of the hype phase of wild R&D into steady growth, industrial adoption, and a shift towards production-focused applications. It is now in its deployment phase. Companies are scaling cautiously and focusing on retention rather than aggressive recruiting. So, who is actually getting hired? The report reveals a massive pivot toward production and software. 75% of companies plan to expand their shop floor staff this year. They are looking for machine operators, technicians, and quality control inspectors, people who can keep a fleet of printers running 24/7. They don't need generalists. They need reliable factory workers. On the white-collar side, the general AM expert is out. The demand is now for highly specific technical skills, software engineers, computational geometry experts, and application specialists who can solve complex integration problems. Regionally, the competition is fierce everywhere, but it is hardest in the Asia-Pacific region, where the ratio spikes to over 300 candidates per job. In North America and Europe, it hovers around 130. The takeaway for job seekers is simple. General passion is no longer a career strategy. To survive this market, you should specialize. The industry is professionalizing, your resume should do the same. For more insights on the job market, check the link in the show notes.
Metal 3D printing usually means you'll need an industrial, million-dollar machine to produce a part. But a technology called cold metal fusion is changing the game by letting you print metal parts on the same machines we've used for years. Here is how it works. Instead of melting metal powder with a high-powered laser, cold metal fusion uses a clever trick. It takes metal powder, like stainless steel or titanium, and coats every single grain in a thin layer of plastic. Because of this coating, you can load this metal ink into a standard, low-cost SLS printer, the kind usually used for nylon. The printer's weak laser melts just the plastic coating, gluing the metal particles together at a cool 80 degrees Celsius. What you get out of the printer is a green part. It looks like metal, but it's held together by plastic. You then pop it into a furnace. The heat burns away the plastic and fuses the metal particles into a solid, dense object. The drawbacks? It can lead to significant shrinkage of up to 15% and potential warping, requiring careful post-processing and good 3D design to counter the drawbacks. The benefits? No support structures are needed so you can stack parts. There's also no thermal warping during the print. And most importantly, it turns affordable SLS desktop machines into small industrial metal factories. At All3DP, we have an in-depth article waiting for you if you want to drill deeper into the topic.
The artificial intelligence boom has a hidden cost, and that's heat. As data centers scale up to power AI, their energy consumption is expected to at least double, with a massive chunk of that power used just to keep servers from overheating. But a new 3D printed solution from the Danish Technological Institute addresses the problem without using a single extra watt of electricity. Developed in partnership with startup Heatflow, this new heat exchanger operates with no pumps and no fans. It utilizes a thermosiphon principle, a passive two-phase cooling system where liquid evaporates at the hot surface, rises, condenses, and falls back down thanks to gravity. By using metal 3D printing, the team created a complex, single-piece aluminum evaporator that integrates multiple functions into one leak-proof unit. In tests, the prototype crushed its targets, achieving a cooling capacity of 600 watts. Even better, the system captures heat at temperatures high enough, between 60 and 80 degrees Celsius, to be fed directly into district heating grids. That means the waste heat from your ChatGPT query could literally heat a nearby home. With potential CO2 reductions of up to 30%, this is a rare win-win situation for big tech and the planet.
And now a word from our sponsor.
Are you an engineer or designer looking for high-precision CNC parts? Tired of waiting for manual quotes? Stop waiting. Craftcloud is your solution for instant on-demand CNC machining. Upload your CAD file, select from a wide range of materials, and instantly compare real-time quotes worldwide. Get the best price on precision parts, from rapid prototypes to mass production. We offer 3-axis and 5-axis milling, turning, and more. No minimum orders, just transparent pricing, fast delivery, and expert service. Craftcloud. We turn your CNC ideas into reality.
Here are the news bulletins. Subaru of America reports it has cut tooling development time by over 50% and costs by 70% using a new Stratasys printhead. The team retrofitted their Stratasys F770 printer with the new T25 high-speed head, which prints up to 2.3 times faster than previous iterations. This allows them to produce large-format assembly jigs, some up to 36 inches long, in-house in days rather than waiting weeks for outsourced CNC machining. The Blender Foundation has released a new, completely free course titled 3D Printing with Blender. Taught by veteran instructor Hulti Hjalmarsson, the course is specifically designed to demystify Blender's complex interface for beginners. It skips the animation tools to focus strictly on modeling, troubleshooting, and repairing meshes for physical 3D printing. It is available now on the Blender Studio website. All3DP has updated its definitive Best 3D Printers Buyer's Guide for 2026. The top pick for best under $1,000 is the Creality K2 Pro, praised for its active chamber heating and multicolor capabilities. For the under $500 category, the Bamboo Lab P1S takes the crown, while the budget-friendly under $300 spot goes to the new Elegoo Centauri Carbon. The guide also highlights the Prusa Core 1 as the best premium enclosed option.
That's it from the weekly roundup from the world of 3D printing. As usual, you can find all the links in the show notes. Thank you to our sponsor Craftcloud, and remember, you can always find more in-depth articles, reviews and guides at all3dp.com. Don't forget to subscribe and leave us a rating or review. It really helps us to bring these updates to even more 3D printing enthusiasts like you. Join us next week for another rapid-fire update. Until then, happy printing!